Hi everyone, welcome back to this new video in the system design series. In this video, we would be learning about API gateway. We'll mainly learn two things. First is why do we need API gateway? And the second is the different use cases of API gateway. All right, so let's get started. So now let's first try to understand why do we need API gateway. Okay, so in order to understand that, let's remove this API gateway from here. Done. And by the way, I am assuming that we are using microservice based architecture like this. Why? Because API gateway is commonly used when you have microservice based architecture. That's why I've taken multiple microservices. Okay. So now let's try to see some of the problems which we are going to face because we have removed API gateway. So the very first problem is your front end needs to call each of the microservices directly. Okay, it means that they need to note down all the URLs of your microservice. So currently there are 5 microservices. So front end team has to note down 5 URLs. If you would have 50 microservices, then front end team needs to maintain 50 URLs, right? And wherever you are calling the backend, in that case, you have to use appropriate URL. If you want to call service B, then in that case, you need to use this URL. You cannot use this URL, obviously, right? So this is additional complexity. Front end team has to maintain all the URLs, 50 URLs, just imagine. So this is not a good thing. So this is first problem. The second problem is obviously there would be some APIs which needs to be authenticated. So assume that this is user service which would have a URL like a API like profile. Okay. Let's say this is booking service which would have API like book. Okay. Which would basically book a particular movie ticket, right? Let's say this is payment service and the API is checkout, right? Okay. So all these APIs can only be called if you are authenticated, right? It means that all these microservices needs to implement authentication. Okay. They need to implement this authentication, all these microservices. Okay. Similarly, this microservices will also have some, let's say, admin endpoints, right? So in that case, they also need to implement authorization. Okay. Also, this microservices needs to rate limit the URL, because if you don't rate limit these URLs, then obviously any user can spam your microservice, right? Spam your backend. And definitely we don't want that. So that's why we need to implement rate limiting in all the microservices. All right. So I think you can clearly observe the problem. The problem is all these microservices are basically implementing this same thing. So we are duplicating the code. The code which you are going to write in service B for authentication needs to be duplicated in all the services. And most probably, if you are working in, let's say, some big tech company, in that case, each of the services will be handled by different team. So there are chances that some team might also introduce bugs when implementing this authentication logic, right? So there are lots of problems because you have removed this API gateway from over here, right? So this is the main reason we need API gateway, right? So I hope now you understood why we need API gateway. Now let's see the different use cases of API gateway. The first use case is routing. Before that, let me show you this thing. So now the front end will only call the API gateway. That's why the front end will only need one URL, which is the URL of API gateway. Okay, it does not need the URLs of all the microservices, right? So now let's focus on this point, routing. So if let's say this front end wants to call the user service, right? But we only have the URL of API gateway. right? So the request will only go up to this point. Then how come we would be calling this user service, right? How come we would be getting the data from the user service? So the thing is, in API gateway, you can implement routing. So if you have ever used Spring Cloud Gateway, then you might be knowing this particular structure, wherein you would be writing a routing file wherein you would be mentioning the path, okay, and where that particular request should be forwarded. If the path has users, then that request should be forwarded to user service. If it has payments or checkouts, then it should be forwarded to payment service, and so on and so forth, right? So this is how we basically implement routing in API gateway, okay, right? So this particular URL will first go to the API gateway, and after this URL you would be having some you can say suffix like users or checkout or something like that. Based on that, you would be redirecting the user to the appropriate microservice, right? So this is the very first use case, okay. The second use case is authentication and authorization. So for that, what you are going to do is in API gateway itself, you would be first getting the JWT token. By the way, I'm assuming that you are using JWT based authentication. So you would be first getting the JWT token from the cookies or headers, and then you would be validating that. Okay. And probably you can also check the roles if, let's say, there are some URLs or APIs which only admin should be able to call, right? So if everything is satisfied, then only you can forward the request to the appropriate microservice. Else you can block the request, right? So this particular logic is now common. Okay. Earlier, all of the microservices were supposed to implement this logic, but now only API gateway will implement that logic, right? So this is the second use case. Again, third use case is similar. Instead of all the microservices implementing the rate limiting, only API gateway will implement the rate limiting. All right. So this is the third use case. The fourth use case is logging and tracing. So let's say the order of some user got failed at 2:43 p.m. Okay. Now you need to trace the request and know the root cause of this, right? You cannot do that without API gateway, okay, without any request identifier. Why? Because see, in order to know the root cause of this, you need to first of all search the log file of all the microservices which is involved in creating the order, right? So you would be searching all the log files and based on the user ID. Okay, so you would be getting the logs of a specific user. But the problem is, first of all, you would be getting the logs of a specific user from order service, right? And you would be also getting the logs of a specific user from payment service. But how come you are going to stitch this? That is, how come you can guarantee that both of this log belongs to the same request which user made at 2:43, right? Even if, let's assume that you can find out that both of this log belong to the same request, but it involves lots of manual work. Agree or not? It involves, right? So definitely you are going to waste a lot of time. Okay, you are going to waste a lot of time in order to find the root cause of this. But on the other hand, if you use API gateway, then what you can do is, first of all, the request will go to the API gateway, right? When the request goes to the API gateway, in the API gateway, you can generate an unique identifier, unique request identifier. Okay, let's call that as trace ID. And we'll put this trace ID into the header. Okay, so all the downstream services will be using the same header, this header. Okay, and they would be logging. But apart from that, they would also add this particular identifier into that log. Okay, in the log you would be having lots of stuff like user ID, this, that. Apart from that, we would also add this thing. All right, and all these log files are basically sent to some centralized store like Datadog or anything similar to that. Okay, wherein you can filter the log based on some parameter. Okay, so here we would be filtering the log based on the unique request identifier or trace ID, which is this. So once we filter this based on this identifier, we would be getting the entire trace of this request. Okay, we would be getting that first the request went to the gateway, then it went to the order service, then it went to the payment service returned 402, and that's why gateway returned 402, and that's why order got failed, right? So this is how I can find the root cause, right? And I can also fix the problem if it is problem from backend side. If it is problem from client, then I can inform the client, right? So this was the fourth use case. What about the fifth? The fifth is protocol translation. Let's say all of your microservices uses gRPC protocol. Okay, it is one of the protocol similar to REST. Okay, REST protocol is I think we all might have made some project using REST protocol, so we all know about REST protocol. But there is one more protocol which is gRPC protocol, and it is very faster compared to REST. Okay, and it also takes less amount of space compared to JSON. See, in REST protocol we use JSON, whereas in gRPC protocol we use protobuf, which takes less size compared to JSON. Okay, so that's why all these microservices uses gRPC. This is our assumption. All right, so they are using gRPC, but this client understands REST or it uses JSON. So there is protocol mismatch, right? So what we can do is, whenever the request goes over here from the client, we can convert this REST protocol to gRPC protocol and forward that request to the microservice, since microservice only knows gRPC. And then microservice will return the gRPC response. Okay, so we will again convert that response to JSON response, that is REST protocol, and send that to the client. So this is the fifth use case of API gateway. All right. Coming to the sixth use case, which is Canary deployment. So first of all, what do we mean by Canary deployment? So see, let's take one real example. So a few years back, Netflix basically upgraded their recommendation system, okay, for recommending the movies and the shows, right? So earlier they were using some algorithm, but then they upgraded that algorithm. But the problem is, any large companies cannot risk exposing this new algorithm directly to 100% of the traffic. Because what if this new algorithm starts throwing error in production, right? Then entire recommendation system will fail, right? Basically, no one will get any recommended movies or shows, right? So what they generally do is, uh, the 95% of the traffic will still use current algorithm, and only 5% of the traffic will get access to the new algorithm. Okay, so first they will only allow 5% of the traffic to use this new algorithm. Okay, and slowly and steadily they would bumping up this 5% to 10%, then 20%, then 100%. Okay, and they would only bump up this particular percentage if they don't face any errors. Okay, let's say those 5% of the traffic got some error, right? Then they would directly forward those traffic to the current algorithm and try to solve this part. Okay, so this is what Canary deployment is. Okay, slowly and steadily you are rolling the updates to the end user. Okay, so this particular Canary deployment is one of the use case of API gateway. Okay, using API gateway, or in API gateway, you can implement a logic for Canary deployment. All right. The next use case is backend for frontend. And backend for frontend is generally used for mainly two reasons. The first one is response aggregation, and second one is reducing the number of round trips. So let's try to understand both of them one by one. Before that, let's assume that we are dealing with some food delivery application. So you would be having multiple microservices like restaurant service, order service, user service, etc. Okay. And let's also assume that this particular application is available on App Store as well as website as well. Okay, so you can access this using your browser as well as mobile app through your phone. So the thing is, obviously, in your website, you would be able to show a lot of stuff because it has a big screen. Whereas in mobile, we have a small screen. That's why we should be only showing limited amount of data, right? And since we are only showing limited amount of data, we should only fetch limited amount of data. The website will fetch, let's say, 10 things. Then mobile app cannot or should not fetch 10 things, because see, mobile app is generally connected to your mobile network. It is not connected to your Wi-Fi in general. So that's why mobile is generally slow compared to your laptop or your computer, right? So that's why you should only fetch less amount of data on mobile. So what we generally do is we create APIs based on the client. For web, we would be creating one API. For mobile, we would be creating one API. Okay. And this API will be called by mobile, right? So mobile will call this API. An API gateway behind the scene, it would call the respective services. Okay. So for example, let's say this is the data which you want to show on the mobile screen. So you would be calling the user service, the offer service, and the restaurant service. Over here, I have aggregated the result from different services: user, offer, and restaurant. And I'm sending the response as one particular object. Okay. And also I am only sending those things which are needed by the front end. Surname is not needed, age is not needed. So there is no need to send that particular stuff. All right. So this is what backend for front end is. Okay. And that thing is implemented at the API gateway level. Okay. API gateway will call the different microservice. It will aggregate that and return the response, right? Based on the client. So this is the first response aggregation. The second one is reducing the round trip. So if, let's say, you remove the API gateway, in that case, this mobile has to call user service, restaurant service, and offer service. So how many network calls? 3 network calls. And obviously mobile is generally connected to mobile network. That's why it would be very slow. But if you use API gateway, then only one network call is needed, this one, right? And all the other network call is from API gateway to the respective microservice, and it would be very fast because they all lie in one single data center, right? So it would be very fast. So that's the second advantage of backend for front end, and both of this thing can be implemented at API gateway level. So this is another use case of API gateway. I hope you got this point. All right. Then another use case of API gateway is caching. Let's say you are dealing with some products API. So you can cache the response of products over here. All right. You can cache the products. Why? Because products is not frequently changed. So you can cache the product for, let's say, 10 minutes. Then API gateway can also be used as load balancer as well. So assume that you get millions of orders every minute. So obviously one order service is not enough. You would be having multiple instances of order service or multiple containers of order service. So in that case, this API gateway will be load balancing the request between those instances of order service, right? So API gateway can also be used as load balancer. And apart from that, one more use case is SSL termination. That is, front end will use HTTPS, okay, to connect to this API gateway. But from API gateway to the microservice, you can use HTTP, okay. There's no need for SSL certificate on all those microservices. Only one SSL certificate is needed at this point, okay. So with this, we have covered lots of use case for API gateway. I hope you understood all of them. If you didn't, comment down. Maybe I'll try to reply that. Thanks for watching, and please don't forget to like and share this with your friends.